Welcome back, guys. I'm Ramon Renewal for all you guys that didn't know. Today we'll be implementing the queue data structure in Java, and we'll be doing it using generics. So, in the last video, I implemented the start data structure in C. So today we'll be using Java. And Java is an object-oriented language. So all you guys that can use Java, then this should be easy for you to implement and easy for you to follow along. So let's jump right into it. So the first thing that I'll do is to create an array of item type. Item basically represents the data type that will be replaced when the class is instantiated with a type. So that array represents the queue basically. After that we have size, which stores the current size of the queue. After that we have front, which represents the front of the queue. That's basically self-explanatory. No comment is needed, but it's always good to comment your code. And since we're learning right here, comments always help us. After this, we have rear, which basically represents the rear of the queue. So after this, we create a constructor, since Java is a object-oriented language, and the constructor that we're creating is a primary constructor. So we initialize our array now, or allocate memory to it. That's basically what we're doing. I don't know if allocate is the right word. In C, I would say allocate memory, but I think it's the same thing. We're allocating memory right here. So we initialize front, rear, and size to 0 because currently the queue is empty. So the next operation that we'll do is the onQueue operation. The onQueue operation is basically the insertion operation for the queue, which takes one parameter, which is the item to be inserted. As you can see in the last video, I did the return type first because sometimes I forget to write the return type, so it helps me. So the first thing that we're doing right here is to test if the queue is full. If the queue is full, we return false. As you can see above, I'll be printing an error message. So notify the user that the queue is full. We could have thrown an exception there, but in that case, we don't really need to throw an exception. And for me, I don't really like exceptions. So we're going to insert the item now, and it's basically a one-liner. It's that easy. So we're going to increment rear by 1. The reason why we're using incrementing it like this is because we're implementing a circular version of a queue. And that's basically it for the onQueue operation. Everything within the onQueue operation is practically self-explanatory. So you should understand. So now it's for the dequeue operation. So we're going to test if the queue is empty. If the queue is empty, then obviously we cannot dequeue anything. So we return, I'm used to C. We return null, and we'll print out to the user or notify the user that the queue is empty and we cannot delete anything from the front. For all you guys that didn't know, I'm using Eclipse as my editor. In the last one, I used Vim as my editor for C. So This is where the deletion right here happens. We're going to store the front of the queue, and then after that we're going to set the queue front to null to give back this memory, or to notify the garbage collector that we're finished with this memory so it can collect it. And we're going to increase front by 1. Sorry, we're not going to decrement front. But we're going to decrement size by 1. And we're going to return the item finally. And that's it for the dequeue operation. The dequeue operation is pretty much simple. I don't believe there's anything not to understand. Pretty straightforward. So we're going to return the size now. We're going to have a function called getSize, which basically returns the size of the queue, the current size of the queue. Pretty simple. This is very straightforward. So what we're going to do here is let our queue class implement a iterator so that we can traverse through the queue. The iterator helps us to traverse through the elements within the queue or within any container without knowing the underlying type, because the underlying type is not significant to us. So we're going to create a private class within that's called queue iterator, and this will contain the iterator methods that we'll need. So hasNext. Hasnext is pretty simple. We're going to create a variable called start. I just realized that we needed that. So if start is not equal to rear, then we know that the queue has a next element to display. Sorry about that. So this is the next item that we'll return. So we'll always return the front of the queue. So what we'll do is, after returning the front of the queue, we'll advance start by 1. So we'll go to the next item to return. So notice that start was initially equal to the front of the queue, and each time we advance it by 1, we're traversing the queue. I hope you see that logic. So we're finally implementing the iterator. So the iterator function practically just returns the iterator object. And that's it. After this, I'll be just leaving some comments above the functions or methods to signify what each method does. So the on-queue operation is pretty straightforward. I know you guys already know that. So for the rest of the video, I will not be talking until I'm creating a driver class for this.